When you solve proportions, you'll typically have two fractions equal to each other, since that's what a proportion is, and there are four different numbers that you can have since you have a numerator and denominator for each fraction. One of those four numbers will be missing, and we're going to use cross multiplication or cross products in order to solve for the missing number. So for example, here I know that 6 times 12 and 8 times n must equal each other. I like to start by multiplying whatever has the missing variable, because I like my variable on the left-hand side. So the missing number is n. I'm going to multiply that first. And then I'm going to multiply 6 times 12. So I end up with an equation. 8n equals 72. Now I'm going to solve this equation by dividing both sides by 8 and multiplying by the reciprocal, which is 1/8. So at this point in the year, you know that multiplying by the reciprocal is the same as division. So n equals 9, because 8 times 1/8 is 1. 1 times n is n, and 72 divided by 8 is 9. So that means that 6 over 9 should equal 8 over 12. And I can check this a couple of different ways. I can check this by simplifying my fractions and seeing if they are indeed equivalent. So I know that 6/9 is the same thing as 2/3 if I was to divide 3 into the top and bottom. And I know that 8/12, if I was to divide by 4, is also the same thing. 4 over 4 is also the same thing as 2/3. So that's one way you can check. The easiest way to check when we get into these harder problems is, again, with cross multiplication, with your cross products. So I can figure it out by checking 6 times 12 and seeing if that equals 9 times 8. And we know 6 times 12 is 72, and 9 times 8 is 72. So n equaling 9 is indeed the correct answer. You can check all your proportions, which is really nice. Let's look at some more examples. So for the next example, I have 16 times n, or 16n, equaling 25 times 10, or 250. That's 25 times 10. Now I'm going to divide both sides by 16 to solve for n. Or again, you can multiply by 1 over 16, which is the reciprocal. And when you do that, I'm actually going to click down here for the answer. You see that n equals 15.6 when you divide both sides by 16 in our equation. This is where we were with our steps. So n equals 15.6. So for our check step, we can put 15.6 back in the place of n, which was in the denominator of our second fraction right here. And we can cross multiply. So 16 times our answer, which was 15.6. Figured out this is 15.6. So 16 times 15.6 should equal 250, 25 times 10. And when we put that in our calculator, we do get 250 on both sides. Now, one thing you need to keep in mind in this case is I actually rounded the 15.6. So when you go to do your check step and you multiply 16 times 15.6, you'll actually get 249.6, which is really close to 250, but not exactly 250. And that's because of rounding. And there's no way to avoid that. So let's look at some harder problems. Let's say I had a proportion like this one. 3/6 equals 10 over 9n. I'm going to multiply 3 times 9n. That equals 6 times 10. So 3 times 9 equals 27n. And 6 times 10 equals 60. I'm going to divide both sides by 27 to get n by itself, since that's the multiplication equation. And when I do that, I end up with n equaling 2.2. Now I'm going to go to another kind of problem that gets a little bit harder. Here I'm going to cross multiply 3 times 24 and 5 times n plus 8. When you multiply 5 times n plus 8, remember to use the distributive property. So we're going to get 5n plus 40 when we distribute 5 times n plus 8. So 5 is being multiplied by the n, it's also being multiplied by the 8. And then 3 times 24 is going to equal 72. I need to get rid of the 40 so that the 5n is by itself, so I'm going to add a negative 40 to both sides. I get 5n equals 32. I'm going to divide both sides by 5 to get n by itself, and I end up with n equals 6.4. So let's do another hard example. Here, we have n minus 2 over n plus 8 equals 5/3. So I'm going to cross multiply 3 times n plus negative 2, I'm going to change that subtraction to plus a negative, equals 5 times m plus 8. I can use my distributive property on both sides, so I get 3 times m plus negative 6 equals 5 times m plus 40. I'm going to bring my m's over to the left-hand side by adding a negative 5m. Remember, we're adding 5m and 40, so to get rid of that adding of the 5m, we're going to add the opposite, negative 5m. And we're going to do that to both sides. Do it to one side, you have to do it to the other. So it ends up with negative 2n plus negative 6 equals 40. So we got rid of the 5n where we did not want it. Now I'm going to add 6 to both sides to get the negative 2n by itself and to get all the constants over on the right-hand side. Now I'm going to multiply by negative 1/2 or divide by negative 2, however you want to think about it. It's the same thing. And I end up with m equals negative 23 for my answer. And I can also click here for the steps. One last example with the distributive property. 12 times 5 minus x equaling 9 times x minus 4. So 12 times 5, I'm going to put plus negative here, plus negative here. 12 times 5 is 60. Plus 12 times negative x is negative 12x equals 9 times x is 9x plus 9 times negative 4 is negative 36. Then I'm going to add a negative 9x to both sides because I want to get rid of all my x's on the left-hand side. I don't want any variables over there, on the right-hand side. So that gets rid of all my variables over here on the right-hand side, and I end up with 60 plus negative 21x equals negative 36. Now I'm going to add negative 60 so that all my constants end up over on the right-hand side and all my variables are on the left-hand side. When I do that, I'll end up with negative 21x equals negative 96. I'm going to divide both sides by negative 21 in order to get x by itself. And when I do, I end up with x equaling 4.6. So there are a couple of examples to help you with solving unknowns within proportions.